Hello all, welcome back to our YouTube channel. So in this video, we just going to talk about the uniformly accelerated motion. In particularly, we just going to talk about motion under gravity. Okay. For that, I just need a assistance of kinematic equation. So first, I just introduce. First, in this video, we just going to talk about uniformly accelerated motion. But in particular, we will only focus on motion under gravity. For that, we just need a assistance of kinematic equation. Okay, so kinematic equations. So let me give that. What are the kinematic equation? And then we will go with motion under gravity. The first equation, kinematic equation, I just used to give that. So V equal to U plus AT. Let me introduce the terminologies used in this equations. Okay. V square equal to U square plus 2AS, and then S equal to UT plus half AT square. So these are all the kinematic equations for a motion. So we can study any kind of motion with this three equation. We can easily solve everything with this equation. Let me tell what are the terminologies involved in this. So V stands for final velocity and U stands for initial velocity, A is for acceleration and T for time taken, and S is for displacement. Okay, so these are the kinematic equation. So let me introduce, talk about the motion under gravity. So let me take it. So motion under gravity. So in this topic, what we going to cover is when any kind of object which is going in gravity, okay, it's maybe towards, in the direction of gravitational field or against the gravitational field. We can call it as upward motion and the downward motion. First case, I just want to take an object in upward motion. Okay, upward motion. So let me explain what it is and how it works and how the formula came. Everything we will give it here. So what it is? So here's the ground. Okay, so one ball is, some object is here. So what I am going to do is I am just going to project this ball in upward direction like this with some initial velocity, something which is not equal to 0. Okay, I am just going to project this object upward. So what will happen? The gravity continuously, what it will do, it will continuously pull the object downwards, right? So because the gravity acting downwards, so just keep a one point in your mind. If the object is going towards gravity, which is downward motion, we have to put the acceleration A equal to plus G. Okay, so if the object is going against gravity, which means upward motion, we have to put acceleration as A equal to minus G. Just keep the point in your mind. So in this case, it's an upward motion, the ball is moving against gravity, right? So we can write it out, A equal to minus G. Why it is? It's upward motion, right? So you just think about this, just imagine what will happen. So when you throw the ball upwards, so you may experience in your real life, right? So you are playing with a ball, something like this. So what will happen? You are throwing the ball with some velocity. At each moment of time, the gravity will attract the object, right? So what will happen? When you project this object with some velocity, the velocity will eventually reduce, right? So then what will happen? The ball try to go upwards, the velocity slightly goes down. At particular moment of time, the velocity terms completely vanish. The ball completely stops at maximum height for that particular velocity. Then what will happen? The ball again comes down, right, towards earth and will land on earth. So I just want to confess something in this topic. So what are the points? So just carefully listen what I am going to tell in next 1 minute. So you are projecting this object with some velocity u. Okay, so what will happen? So the gravity will attract it and will definitely get slow down. So it will reach some maximum height and it come back and comes down and land on earth, right? So just we are neglecting the air resistance involving in atmosphere. Okay, so just keep in mind. So ball, it takes some time to reach maximum height. Okay, for example, the ball reaches maximum height in 1 second, and definitely the ball will reach the ground in next 1 second. I hope you understand, right? So the ball, if it reaches the height, maximum height in 1 second, definitely the ball will reach the ground again in 1 second. So this is the key point you have to remember, okay? And one more thing is, if you are throwing the ball with some velocity, right, u is not equal to 0. So the ball, it goes up to the maximum height, completely stops here. So at that particular point, the velocity becomes 0, right? So it will comes down and hit the ground. So when it hits the ground, okay, the velocity will be same like the initial velocity. These are the things you have to carry in your mind. So let me redefine our equation of motion. We have given the kinematic equation, right? So we are just going to modify this equation according to this model, okay? So already I am telling that in this model the acceleration is a gravitational acceleration. So I hope you all know that what is the gravitational acceleration. G is equal to 9.81 meter per second square. So while problem solving, I will take it nearly equal to 10 meter per second square. So it makes our problem very simple, right? So in some scenario I just use that value 10, okay? So no problem. So let me redefine that equation. So this equation, I just want to redefine this equation according to this motion under gravity, upward motion. So same thing only. So final velocity V equal to initial velocity. So we have to put here with the place of A, we have to replace with the A with the minus G. Why? It's going against gravity, right? So it becomes minus GT. This is our new equation, and the second equation just going to modify V square equal to U square minus 2GH. Okay, why I am putting H? Because we are dealing with some height and everything, so we are replacing the displacement with height. So nothing more than that, okay? Very simple only. So next third equation is becomes H equal to UT plus half AT square. It will becomes, right, 1 by 2 GT square. So this is our new equations for this kind of motion. So let me discuss more on this. So we are going to break all the formulas from this. So I just told you before few terminologies, right? So the object going upwards, we are projecting with some velocity. In how much time it will reach the maximum height? That's the one question. And we are projecting this object with some velocity. How much distance it will reach? How much height it will reach? That's going to be a second question. And third question will be, if I am throwing the ball with some velocity, how long the ball will in the air? So this is going to be a third question, okay? Basically we say that how long the ball it will be in the air. So we can say that's a flight time of a ball, okay? So let me solve one by one. The first thing is I just going to tell T max. So T max is what? So time to reach maximum height, okay? Time to reach maximum height. So that is what T max is, okay? Let me derive it. So for that we have to choose an equation. You just think that from this three equation, to find a T max, what equation you have to take? I know the initial velocity, I know the final velocity. At maximum height the velocity becomes 0. So I have the information of U and V, and the G we know that, right? So I have to pick the first equation, okay? So let me take it. So V equal to U minus GT. We know that at maximum height what will happen? At maximum height the V becomes 0. It's a final velocity, becomes 0, right? So then our equation becomes 0 equal to U minus G into T max. We are applying conditions, we have to take that only, okay? So we will solve it, and just bringing the GT max to that side, it becomes GT max equal to U. So we are going to find maximum time to reach maximum height is T max equal to U by G. That is our equation. So just remember in your mind, okay? Simple. So I am just going to derive another thing. The second one is I just wanted to derive as maximum height the ball will reach, maximum height, okay? Let me take the equation. So in this case you just think that for this scenario which equation you have to take. So you have a information about initial velocity and final velocity and the gravity, right? You don't have the information of time period. So which equation you have to choose? So I need a height also, right? So I would like to take the second equation. So here I have u and v and h. So I just take the second equation. Simple. So the second equation is what? V square equal to u square minus 2gh. Okay. Let me apply the condition. At the maximum conditions, the velocity becomes 0, right? So if I plug in all the details here, I will get 0 equal to u square minus 2g h max here. Where it's h max here? That's a maximum height. We are just going to find it, right? So let me take 2g h max equal to u square. Simply the h max formula is simply just bringing the 2g down there, we'll get u square by 2g. So this is our h max formula. So by using this formula we can solve this very easily. So let me find the final one also, then we will go with another thing and we will solve problems regarding this. Okay. So let me take the third one. What will this? Third one is the flight time. Flight time is what? How long the ball will be in a rest of in the air, right? So for that I just told you before, right? So how much time it takes to reach maximum height? The same time it takes to comes to the ground, right? So simply we can say the t flight. Okay, the t flight is 2 times of t max, right? Simple. The 1 second it takes to reach maximum height, again the 1 second to comes down to the ground, right? So we will say the time of flight equal to t 2 times what is t max? U by g, right? So u by g. This is the equation. This is how physics. Okay, very simple. You just have to feel it, how it is and how it works. You just apply the conditions, you will get everything, right? So this is motion in upward motion. Okay, so let me solve another one. So motion towards gravity. The second thing, motion, downward motion. Okay, so next thing is downward motion. Okay, in this case we are just going to, we have some building. Okay, we have some building. So a man is standing on the building. So we have a ball right there. So we are just going to drop a ball. Here there is two conditions. One is we are going to drop a ball. So drop a ball means what? We just having our ball on our hands. We just releasing it, right? So we are releasing it. It means drops. So if you are dropping the ball, so initial velocity becomes 0. There may be some other conditions like we can throw it, right? So from the top of a building we can throw the ball. So in that case the initial velocity is not equal to 0. So that's a different condition. So let me take one by one. The first thing I just want to take is drop. I am just going to drop a ball. So what will happen if I am going to drop a ball? Initial velocity is 0, right? If I am just dropping it, the gravity acts on an object. So definitely the velocity will increase at a time increasing. So then at some time it will reach and hit the ground. Okay. So in this case we just going to find a few things. What we are going to find? So before that I just wanted to redefine the equation for this kind of motion, downward motion, right? So again you have to go back to the kinematic equation. I hope you guys all know that. So let me directly do that. So in this case the object is going downwards. So the acceleration becomes plus g, right? Why plus g? Gravity acting downwards, the object also going downwards, right? So the a is going to replace with g only. So in our kinematic equation is going to be converted into v equal to u plus gt and v square equal to u square plus 2gh and h equal to ut plus half gt square. This is our new kinematic equation for this downward motion. Okay, so now we are perfectly ready. So now just going to solve one by one. So let me tell. So what are the things we are going to find from this case? So we are just going to find. So we have the building some height, right? So I have a building at some height. This is the height of the building. We are just going to drop a ball. So if you are dropping the ball, in how much time it will land on a earth. So that's going to be a first question. And if you're dropping a ball, if you is about to hit the ground, right? So at what velocity it will hit the ground or it will land on a ground. So this is my question. Okay, so two things, one is the hitting velocity and the time period of travel. Okay, so this is I'm just going to solve from this. After that I just wanted to solve for throwing the object from the same building. Okay, first I'm just going to drop it. So it just is the same equation, you will get everything, man. So very simple. So first thing I just wanted to solve time to land. Okay, time to land on a ground. So you just think about the information on your hands. So in this case I have two information, right? One is initial velocity, it's going to be 0. Another one is the height of the building. So by utilizing these two data, I have to find the time period equation, time to land. Okay, just think that. So which equation you have to choose? You can use first equation, huh? No, you don't know the information about the final velocity, so we can't use it. Second equation you can use it, right? So because the final velocity we know that, we don't know that, so second equation also we can't use. So we can use the third equation. Okay, so we have to find the height. We know the height h equal to initial velocity becomes 0 plus half into g into t square. This is the landing time. Okay, just bring that 2 and g to that side, we will get t land square, it becomes 2h by g. So the time period, time to land on a ground is becomes, so we are taking the square root on both sides, we will get simply 2h by g. So this is our equation for finding the time period of time to land from some height if you are dropping a ball. Okay, okay, let me solve one more thing. So the second thing is become, okay, so next thing is will be the velocity. Okay, so velocity hit. So the ball reached the ground, right? How much, what is the velocity when the object hits the ground? So that's the simple thing. We know the information. So what are the information we know? Initial velocity is becomes 0. We know that, right? And we know the height information, and we are just going to find the final velocity. You just think that which equation you can use. So you can see the second equation, v square equal to u square plus 2gh, right? So in this case we can use it. Okay, so let me take that equation again. So v square equal to u square plus 2gh. In this equation initial velocity becomes 0. Then the equation becomes that this is what our hitting velocity, right? So this is our landing velocity or hitting velocity. V hit equal to 2gh. So what is our hitting velocity? V hit equal to under root 2gh. This is our equation for finding the velocity when the ball hits the ground. That's simple it is. So with the help of these equations we can solve any model from any question from this model. Okay, so I having some questions, some interesting questions. Let me solve it, so then you will get some better idea and a grasp on this concept. Okay, so let me take this problem. If you don't understand anything in between this concept, just go back. Okay, just go back and look again. You will definitely you will understand it. Okay, so okay, this is the question we are just going to solve here. And just read it. It's very nice and interesting question. Let me see what it is. A rocket is fired vertically up from the ground with a resultant vertical acceleration of 10 meter per second square. The fuel is finished in 1 minute and it continues to move up. Okay, so I hope you understand. So what I am going to try to tell here, a rocket is fired vertically up from the ground with a resultant vertical acceleration. So that point is very important. Resultant vertical acceleration of 10 meter per second square. The fuel is finished in 1 minute and it continues to move up. Okay, so from this data they are asking two questions from that. So the first question is, what is the maximum height reached? Okay, what's the maximum height it can reach? The second question is, after finishing fuel, calculate the time for which it continues its upward motion, right? So the rocket is, let me explain what it is. Very simple. So we are just going to launch a rocket, right? Just going to launch a rocket. So this is our rocket. Let's think it. Just you just plus adjust with this diagram. I'm not good at drawing. Okay, this is our rocket. Okay, I hope it looks like rocket somewhat. Okay, we're just going to launch a rocket. So with some initial acceleration, right? So the initial acceleration, resultant acceleration will be, they given in equation is becomes a equal to 10 meter per second square. So this is our resultant acceleration. So we know that if we are launching a rocket with some acceleration, its velocity keep on changing at each moment of time, right? So what will happen is, the question they clearly tell that the fuel will be lost only for 1 minute, right? After 1 minute the fuel gets over, right? So the fuel gets over means no longer the rocket will accelerate, so it won't accelerate, right? So during the time period of 1 minute it will accelerate and it will reach some maximum velocity. Okay, maximum velocity. After that what will happen? It cannot accelerate, right? After the 1 minute it will go under gravity, right? Just think about it. So for first 1 minute it will move in a resultant acceleration against gravity. Okay, this condition will not lie under motion under gravity. Just think about it. It becomes uniformly accelerated motion. After 1 minute the field gets over, then what will happen? The gravity will act, it will do its duty, right? So the rocket reaches some maximum velocity, then what will happen? The velocity will slow down, right? Will slow down continuously, slow down. After some time, okay, after some time it will completely stops, right? Completely stops. So and then what will happen? Then it will falls down towards earth and will reach the ground with some velocity, whatever it is. Okay, so this is the condition they are given in this question. So from this I hope you are understand the concept very well. Let me solve it. What is the maximum height it reached? So in this condition there will be a 2 stages. What is the 2 stages? Yeah, the first stage is the 1 minute time period, right? For example, in 1 minute the rocket may reach this particular point, right? So from this point it will accelerate with this 10 meter per second square. In that particular point the fuel gets over. So it's a 1 minute journey, right? 1 minute journey. So if for this particular time it will reach some height, which is, I can take it as h1. I hope you understand h1. After the 1 minute what will happen? What will happen? So the gravity will act on a rocket and the rocket will get slowed down. So then it moves under gravity. So let me take it in a different color. Then it moves under gravity and reach some height. Okay, I like to take this height as here, height as h2. Okay, the h1 is belongs to the uniform accelerated motion. Actually the resultant 10 meter per second square. The h2 is belongs to the motion under gravity, right? So this is the scenario. So from this data they ask in 2 questions. What is the maximum height reached? What is the maximum height? h1 plus h2. That's it. Second question is, after finishing fuel, calculate the time for which it continues its upward motion. Okay, so from h2 time is there, right? h2 distance is there, right? So to reach that height, particular height, how much time it will take? That's the question actually. So we can solve it now. We are completely ready with the concept. If you don't understand anything, just go back and play it again. We will definitely understand. Okay, let me find h1, first case. So the first case, it is traveling for 1 minute, traveling for 1 minute in an acceleration of 10 meter per second square. Of course the initial velocity becomes 0 because we are landing from the earth, 0 to some velocity. Initial velocity becomes 0. We have to find the final velocity. We can find the final velocity and we have to find the height also, right? So first our target is to find a h1. So for that I just wanted to take a help of kinematic equation. Let me take third equation. Okay, motion under gravity, s equal to ut plus half at square. This is the third equation you got, right? So from that s I just replace with h1. h1 equal to initial velocity is 0, right? 0 plus half into acceleration is what? 10 meter per second square time period is what? 1 minute. So we have to substitute everything in a proper manner. So I just want to use SI units here only. So the time period is 1 minute. So 1 minute belongs to 60 seconds, right? So I'm just going to take it everything in a SI units. So 1 minute 60 seconds, right? So 60 square. So let me find the H1. H1 equal to half into 10 into and 60 into 60. Let me solve it. Okay. If you solve this, you will get like here you will get a 30, right? So if you multiply it, 3 6 are 18, you will get 18 and 1 2 3 zeros, right? This is the H1. We just found a H1. Let me take it in kilometers, right? So this belongs to 18 kilometer. I just found a H1. Let me find the H2. Okay. So if I just want to find H2, the gravitational part, gravity part. So for that I just want to find the final velocity. Final velocity means what? At the end of the first minute here, what is the velocity? So I just find the velocity of the object at the end of the 1 minute. Okay. For that I just take the assistance of the first equation, v equal to u plus at. So we know that initial velocity becomes 0, final velocity v equal to, it is 0, a is 10 and time period is 1 minute, belongs to 60 seconds. So it is 600 meter per second. This is the velocity at the end of the first minute. I hope you understand. Okay. This is the maximum speed it can reach, right? After that the fuel is not there, right? So it will decelerate in a gravity. So let me find the H2 also. So next target is what? We have to find H2. Okay, to find H2, it is moving under gravity. So what are the information we have on our hands? Right, we have a equation, right? At this particular point, the velocity is 600 meter per second. This is the information we got, right? So it is moving against gravity in a gravitational acceleration. Here is the velocity becomes 0, right? Here the velocity becomes 0. Okay, in this case I used to take it's a u here. This is a u. The second case it's a v. V is going to be 0. Final velocity, maximum height is going to be 0, right? U is going to be 600 meter per second. That's it. I'm just going to reset and going to find H2. How to find H2? Let me take the equation second. V square equal to u square plus 2g H2. Why is H2? Second one, right? So we have to put minus there. Why we have to put minus here? Because we are moving against gravity. Minus 2gh, right? Okay, minus 2gh. Let me apply the conditions. Final velocity becomes 0. It is 600 square minus 2 into g h2. Okay, so this is simply 2g h2 is equal to 600 into 600. H2 equal to simply 600 into 600 divided by 2 into g. I just take like a 10. So then we can find it is it becomes 30. Again we will get 18,000 meter. So then the H2 it becomes is what? H2 is become 18 kilometer. Nice, right? So the second distance also 18 kilometer. H1 also 18 kilometer. Okay, we just found the two things. So the maximum height it can reach. This is the first question. It becomes H1 plus H2. We can say 18 plus 18. H is equal to what? It is 36 kilometer, right? So in this motion it can reach up to maximum 36 kilometer. Okay, so let me find the second question also. We will finish the session with this. The second question is what? After finishing the fuel, calculate the time for which it continues its upward motion. Okay, so for the second portion of motion, right? The second portion of motion, we know the velocity, which is, you can say 600 meter per second. It is the final portion of the motion. It is 0, right? So the distance is what? The distance is 18 kilometer, becomes 18,000 meter. So from this information we can calculate the, so I think this is also no need actually, it is going under gravity. I can use the equation V equal to U minus GT. That's very simple, right? We can use it easily. So U becomes 0, U becomes 600 minus G is 10 and the time T. Okay, 10T equal to 600. So the time to reach the maximum height from that particular point will get us 60 seconds. Okay, so everything looks lame. Okay, this is what we found. I hope you understand. Let me summarize this question once again. So is the ground, we just launch a rocket from the ground with some initial acceleration which is become 10 meter per second square, right? So the initial velocity is 0. Yeah, it's from rest only. So what will happen is the rocket which goes up with some resultant acceleration. So the fuel only lasts for 1 minute. It belongs to 6 seconds. So after that it will reach some maximum height. We just found that it is 600 meter per second. So then what will happen? So then no longer the fuel to accelerate the rocket. Then the rocket goes under gravity. Then it decelerates under gravity. It reaches some maximum height. Okay, we just found that maximum height from this point is 18 kilometer, and this distance also 18 kilometer, and overall 36 kilometer. 36 kilometer from the ground, it's a maximum height the rocket can reach. And the time we just found it, right? So what's the time after finishing the fuel, how much time it will takes to reach the maximum height? That's we found this time is belongs to 60 seconds, right? From here to there. I think you understand. So this is how simple is this topic is. Okay, I hope you understand and enjoyed this session well. Okay, okay, thanks for watching. We will meet again with a nice lecture again. Thank you.